Okay, here's part two where I'm going to go in and actually explain what happens. So, question 51 says you accidentally throw your car keys. I hate it when that happens. Horizontally at 8 meters per second from a cliff 64 meters high. So, this is our initial velocity in the horizontal direction. Notice that the keys are not moving up or down as they start. This is the height of the cliff, and the question asks us how far from the base of the cliff should you look for your keys. So, that means we are looking for this distance. Okay, that is a horizontal distance, not a vertical distance. We know the vertical distance they fall is 64 meters. Okay, for most of these questions, the first step is to figure out how long the object is in the air. So we're going to use our vertical information and solve for time. Okay, and that's usually the first step because that's our limiting factor. If the object were in the air for a longer period of time, it would go farther. So the 8 meters per second, being a horizontal velocity, does not play a role in its vertical motion. It is essentially dropped in the vertical direction from a height of 64 meters. So we have final position equals 1/2 at squared plus v sub it plus initial position. The initial position is the initial height, 64. The final position, or final height in the vertical direction, because it lands on the ground, is 0. 1/2 of negative 9.8 is negative 4.9. And then notice this, initial velocity is 0. That is in the vertical direction. This is not 8. That's for horizontal stuff. So subtract 64, divide by negative 4.9, take the square root, and we get 3.61 seconds. Okay, so this motion takes 3.61 seconds. We now solve for this, how far it goes in the horizontal direction. So the cool thing is that in the horizontal direction, the velocity is constant. Okay, gravity pulls downward, not to the side, and we are neglecting air resistance, so we can assume that the horizontal velocity is constant. Is that always the case for these questions? Yes. Am I sure? Yes. Okay, so time, velocity, and distance traveled, 28.9 meters. Okay. 52 says the toy car runs off the edge of a table that is 1.225 meters high. The car lands 0.4 meters from the base of the table. So, real similar situation. There's some initial velocity in the horizontal direction, not the vertical direction. Only we're given information that is different and asked for information that is different from the previous question. We need to find how long did it take the car to fall and how fast was the car going. So, as in the previous question, our first step is to find the time in the air. We use, we analyze the vertical motion. Final position we know is 0. Okay, so this is position. I know people are calling this initial distance and final distance, and that's fine, but recognize that it's in the vertical direction, so this is equivalent to height. Initial height, final height. Final height lands on the ground 0. Initial height, 1.225 meters. Initial velocity in the vertical direction, 0. It was only moving to the side, not up or down. Sorry, it will move in this path, but it wasn't thrown downward. And then 1/2 negative 9.8 for acceleration. We solve for t by subtracting, dividing, taking the square root. And look at that, half a second is the time in the air, or time to fall. Okay. Nice sound effects. For the horizontal motion, sorry, so that was part A, okay, time in the air, or how long did it take the car to fall. For part B, how fast was the car going on the table? So we are now solving for velocity. How fast was it going? This is horizontal velocity. It was moving along the table, so that's what we're looking for. We know we know that it traveled this distance horizontally in this amount of time, so we can solve for this. And again, horizontal velocity remains constant, which is why we can use this formula. So this would be our answer to part B. '53 says a dart player throws a dart horizontally at 12.4 meters per second. So this is a dart. This is its speed. It is being thrown horizontally. Notice how it doesn't travel in a straight line. We're not in the space station. We are on Earth. So gravity will act on it and it will fall like this. Okay. The dart hits the board 0.32 meters below the height from which it was thrown. How far away is the player from the board? So we know it falls this distance. We want to know this distance. Now I think there's a typo in here, so let's be cautious. Notice how I'm starting with vertical motion. I know it falls this distance, so we can say that the initial height is 0.32 and the final height is 0, just as in the previous questions. 1/2 the acceleration, and notice again that the initial velocity in the vertical direction is this, okay, meaning 0. So we subtract, we divide, we take the square root, and this is not right. So I'm going to hit pause, go get a calculator, and we're going to solve this correctly. Okay, back. So we have 0.32 divided by 4.9 equals, oh great.
Don't forget, my little volleyball players, we have brunch for you in the library, so come on over.
0.65306, and then we're going to take the square root of that. So let's see. Aha! Okay. Don't know how I got this answer, but we can put a big X through that. The time to fall was 0.255, so we're going to round to this, seconds, and then in using this answer for horizontal, we're going to put this value in here, multiply it by 12.4, and end up with a horizontal. And so if we were trying to be super specific, we could even say d sub x for horizontal position or distance traveled of 3.17 meters. Okay. So I'm going to just hit stop, and then you'll see the rest of them in part 3 and 4.